All right. Hey, everybody. Welcome to the 10th and final video of the Homework 10 series. So for this question, we are going to be finishing up this Lewis structure right here. Then we're going to give the hybridization for each of the numbered atoms in this compound. They're telling us that the lone pair electrons aren't shown, so we're going to have to add those guys in. So I'm just going to go ahead and skip to the lone pairs. So we can see that we only need 2 lone pairs on this central nitrogen. And again, we're going back to those Lewis structure rules where we make sure carbon has 4 bonds, 0 lone pairs. Nitrogen has 3 bonds, 1 lone pair. We don't have any oxygens in this structure, but oxygen gets 2 bonds, 2 lone pairs. And then hydrogen gets 1 bond and 0 lone pairs. So now we have all of our lone pairs put in there. Now we're going to have to deal with the hybridization for each of the numbered atoms. So if we look at atom number 1, we see that it has 2 electron groups. That means we're going to blend 2 atomic orbitals to make our hybridization. So we're going to be an sp hybrid because we have 2 electron groups for atom 1. Atom 2, we have 3 electron groups. So we have these 3 bonds, and then we also have 1 lone pair. So that's going to give us 4 electron groups in total for atom 2. Since we have those 4 electron groups, then we're going to be an sp3 hybrid because we're mixing 4 atomic orbitals here. For our last one, atom number 3, we again have 4 electron groups. We're bonded to 4 other atoms. That means that we need to blend 4 atomic orbitals, so we're again going to be an sp3 hybrid for atom 3. Okay, now this part B. I think this is probably the more difficult part for hybridization, is being able to identify which atom in the structure matches the hybrid energy diagram that you've been given. So the way that we do these, we've got the hybridized orbitals down here, we've got the unhybridized p orbitals up here. What the arrows in the hybridized orbitals tell us, these tell us about the number of sigma bonds. Each individual arrow represents 1 sigma bond. So that means we're going to have 2 sigma bonds in total. If we had a duet of arrows down here, that would mean that the atom we're looking for has a lone pair on it. But because we do not have a duet of arrows, we know that whichever atom we're looking for up here is not going to have a lone pair. Then we look up here. These are our unhybridized p orbitals. We still have 2 of them. So that's telling us that this is just going to be an sp hybrid. So we need something that has 2 sigma bonds, is an sp hybrid, and then what we're told up here, so these are our unhybridized p orbitals. Each arrow in the unhybridized p represents a pi bond. So that means that we need a total of 2 sigma bonds, 2 pi bonds, and we need to be sp hybridized. We also can count up all of the total arrows, and that tells us how many valence electrons that we need for our species. So we know that this species is going to have 4 valence electrons, and that tells us that we're looking for a carbon atom that satisfies these 2 requirements and is sp hybridized. So if we recall from previously, when we looked at atom 1, we said that atom 1 was an sp hybrid. So if we take a closer look at atom 1 now, we can see that it has a triple bond and a single bond. This triple bond is going to contain 1 sigma bond and 2 pi bonds. And then we also have a single bond over here. So we have a total of 2 sigma and 2 pi bonds around this carbon 1. And it's also an sp hybrid because it has 2 electron pairs, or electron groups. So that means that the atom of interest that's being shown by this energy diagram, that's atom number 1, all right? That's it. That's homework 10. Hopefully this was helpful for you. If not, I apologize. Shoot me an email, send me some comments, do what you got to do. We'll get you the answers. All right. Have a good weekend, everybody.